Welcome back. In today's class, we want to look at redox without oxygen. In the previous class, we defined oxidation as gain of oxygen or loss of electrons, and we defined reduction as loss of oxygen or gain of electron. So if I remove the oxygen part from this equation, if I take away this, both of them, let's take away both of them. So it means we can easily define oxidation as loss of electron and reduction as gain of electron. So there's nothing, we don't have anything to do with oxygen again in this definition. Let's look at this equation, reaction between sodium and chlorine to give us sodium chloride. This reaction does not involve oxygen. We cannot use definition in terms of oxygen, but we can use the other definition in terms of electrons loss and gain. Sodium is 281 here, that is the electronic configuration of sodium here, and in the other side for chlorine it is 287. The way we did for magnesium and oxygen last time, so sodium can lose 1 electron, and then you're going to have 7 plus 1 for chlorine. So this is going to be 28, and this will be 288, and both of them, they have the electronic configuration of the closest noble gas to them. And this is the electronic configuration of NaCl. Na is 28. By losing 1 electron becomes 28, and then plus charge here, and then chlorine is 288, remember, and then it has gained 1 electron from sodium atom, 288, so -1, like this. Now we can write half equation the way we did the other time for magnesium and oxygen. So if let's delete all this, and then we write our half equation now, since we've established that sodium loses 1 electron to chlorine to become sodium chloride. For the sodium half of the equation, the way we did last time for magnesium, we're going to have Na, then the arrow to be to have Na plus electron that is lost. For chlorine half of the equation, we have Cl. We use only 1 chlorine atom, remember the way we did last time. So Cl, and then 1 chlorine atom will gain 1 electron from sodium to give us Cl minus. But we are dealing with 2 chlorine atoms, that is a chlorine molecule. So it means we have to write this equation once again, Cl plus electron to give us Cl minus again. If you combine the two equations, we are going to have Cl2 plus 2 electrons to become 2 Cl minus. Remember, Cl minus 2 of them. So I can delete these 2 now, just for you to understand the concept. That's why I wrote them last time. So we can put this one here this way. Sodium lost 1 electron to become sodium ion, and it is the electron lost by sodium. The 1 electron that is lost by sodium is gained by chlorine, but here you can see 2 electron gains. So it means the way we did last time, we need to balance the sodium half equation to show that sodium actually lost 2 electrons. So we multiply everything up here by 2 electron, 2 sodium atom, 2 sodium ion, and 2 electron lost. So the reason why we are doing that, there must be equal number of electrons lost and electrons gained. So this part of the equation, they may ask you to label it. So what happened here? sodium loses electrons to become sodium ion, and oxidation is loss of electrons. So we can write oxidation here, and at the same time the electron that is lost by sodium is gained by chlorine molecule here. So that is why this process is going to be reduction, because up here we said reduction is gain of electrons. So we can write reduction here. So the sodium part of the equation is oxidation, and the chlorine part of the equation is reduction. So let's look at another example when chlorine react with potassium bromide. It's going to be a very interesting example. It's a reaction between chlorine molecule Cl2 with KBr aqueous, and this is a gas, and then to give us KCl aqueous as well, and then Br2 bromine molecule. We must identify which of the two reactants gains electron, which of the two reactants loses electron. The electron configuration of chlorine here is 2, 8, 7. If you look at 8 here, you know, it is K plus and Cl minus. Of course, you can see Cl minus. That is an extra electron on chlorine over there. So it means chlorine has gained 1 electron to become 2, 8, 8. This is electron gain. And then this is K plus. So if you go back here, it is also K plus. If you split this, it's going to be K plus Br minus. So it is K plus here, it is also K plus here. So we are not going to write anything about K plus. I will talk about that very soon. But for bromide, it is Br minus here, Br minus here, and it's Br without any minus here, Br alone here. The same thing like the same thing we have chlorine molecule alone here. Again, chlorine does not lose electron here, and it does not gain any electron here. So it means chlorine has the same number of proton and electron here. But when they get to this side, we can see that it has 1 extra electron. So it means chlorine has gained electron. So let's write the half equation in the side of chlorine. So I wrote it. I just combined the two chlorine atoms together because we split it last time. So you know already, because we have Cl2 here. So it means we have 2 atoms of chlorine. And then we know that 1 chlorine will gain 1 electron. So because we have 2 of them, it means there are 2 electrons gained here. When there are 2 electrons here, we are going to have 2 chlorine ion formed. So that is the chlorine side of the equation. Let's write for the bromide side of the equation. So here we have to take out bromide from this compound. So we need to write Br minus alone, the one on top over there. So I will write for the bromine side of the equation, it's going to be Br minus. I took the bromine on top only. So this one has electron, but here it does not have any electron. So it means it has lost that electron that it has here to become bromine molecule. So we are going to write Br minus. We put the arrow here. Remember, when there's electron lost, the electron is going to be at the other side of the equation. Then I will write Br2, then plus the electron gain. Remember, it has to be 2 electrons because there are 2 bromine atoms here. 1 will gain 1 electron each. So it means we have to put 2 here as well in order to balance the equation. 2 bromide ion. In fact, the equation up here that I wrote, I did not balance it actually. So if I balance that equation, it will be very, very clear to you. So Cl2, 2 atoms of chlorine, but here we have only 1 chlorine atom. You can put 2 here. So we have 2 chlorine atom. For K, it is 1 here, we have 2 here, we have only 1 here. So if we put 2 here now, we have 2 potassium atom and then 2 potassium atom here as well. You can see that this equation is balanced. Cl2 and then 2Cl, 2K and then 2K here, and then Br2, 2Br. So this equation is balanced. So that is why we have Br2 down here, because of the 2 and then Br here. Sorry, 2Br minus down here, and the other side we have Br2, which is intact, Br2. If you look at chlorine, Cl2, then it becomes 2Cl minus here. This 2 and then this Cl minus to give us 2Cl minus. So the equation is balanced already. Now we have to label the 2 half equation. So the up here is chlorine half of the equation, which shows that chlorine gains electrons. That is reduction. And then loss of electron by bromide ion is oxidation. How do I remember that oxidation is loss of electron and reduction is the gain of electron? There's something we call oil rig. That is the mnemonics that you can use to remember that. I will write it here quickly. Oil rig. So oil rig, the O part of it is oxidation, and then the I is, and then L is loss of electrons. Same thing for rig. The R part of it is reduction, and then the I means is, and then the G means gain of electrons. So that will help you remember that oxidation is loss of electrons and reduction is gain of electrons. Now these 2 equations, we can combine them together. What we write here, remember, this is chlorine half equation and this is bromine half equation. We can combine these 2 equations to give us an ionic equation, an equation that shows the ions that take part in a chemical reaction is called an ionic equation. How do we combine these 2 equations? We did that up there, if you remember. We did combination up here. So, but that is not an ionic equation actually, but we combine. So let's combine this one to give us an ionic equation. I will quickly, I will just take this, take the chlorine part of the equation, and then we put it down here. We take the bromide part of the equation and we put it down here. So we have both of them this way. Then we can combine the 2 equations. Let's draw the line to combine them. The way we did last time, we have Cl2, write the Cl2 part of the equation at this side. This side we have 2Br, it's going to be plus 2Br minus. We go to the other side of the equation, we have 2Cl minus and then plus Br2. So the 2 electrons, they cancel each other's out. So what we have left is what I wrote down here, Cl2 plus 2Br minus to give us 2Cl minus plus Br2. And this is an ionic equation. An ionic equation, if they want you to define it, it's the equation that shows the ions that take part, in the redox reaction. Now I have some question for you. Let's do it together. Here is the question. I want you to pause and try your best and see if you can answer the question. So the question says bromine displaces iodine from a solution of potassium bromide. So our reactants are bromine and potassium iodide. So we can write that Br, we cannot write Br only, remember, it's a bromine molecule, Br2, react with potassium iodide, Ki, and then our product is going to be KBr. If you remember, potassium bromide, bromine displaces, they said displaces iodine from potassium solution. It puts itself in the position of iodine. Iodine was here before, Ki, it now becomes KBr. Br displaces iodine to give us I2. Iodine is now staying on its own in the equation. We have to balance the equation. So Br2, we'll put 2 here, and then we'll put 2 here. This is just like what we did last time actually. Bromine, we write the half equation for the side of bromine. So we're going to write half equation for this side and then for this part. And then we write the half equation for the side of iodine. Write this one, and then for this as well. K does not change. Remember, if I split this, it will be K plus I minus, it's going to be K plus Br minus. You can see K plus and K plus. So that guy is not participating in the redox reaction. A species that is not participating in the redox reaction is called a spectator ion. An ion that doesn't participate in the redox reaction, that the charge does not change. You are going to see that later. So it is a spectator ion. So we don't use it in writing our half equation. So write the balanced half equation for the reaction. So we take the parts of bromine now, Br2. Br does not have any charge here, but here it has minus. So it means it has gained electrons. So it means we need to write that Br2 gains 2 electrons to become Br minus. How many of them? 2 Br minus, because of this 2 here. And again, apart from that 2 here, this is 2 bromine atoms gains 2 electrons. So definitely we are going to get 2 bromide ions. So that is why we have 2 on both sides that way. And this is gain of electron. This is reduction. And then we look at the other side here. We have I minus. I is minus here. I minus at this side, but there is just I. So it means the electron was here before, but there's no electron here. So it means it has lost electron. It's going to be I minus loses 2 electrons, because there are 2 of them, to become I2. So I2, we have to show the electron lost. That is going to be plus 2 electron at this side. So because iodine undergoes loss of electrons, so it means the process is oxidation. So this is oxidation. So the iodine half of the equation represents oxidation. The bromine half of the equation represents reduction. We can combine the 2 equations. They said add the half equation to give equation for the reaction, that is ionic equation for the reaction. So let's combine the way we did last time. When we combine, we're going to have Br2 react with 2I minus to give us 2Br minus plus I2. I'm not taking the electrons because this one will cancel this. So these are half equations, while this is our ionic equation. You can check if everything is balanced or not. So with that, we end this part of the class, and then we are going to look at the other parts, which is another definition of redox reaction actually. So this one is redox in terms of oxidation numbers. So that is also very easy. It's even easier for you to recognize a redox reaction more than using electron transfer that we have here. So see you in the next class. Thank you and bye bye.